Move on to another question. Up the river, down the river. So this question is actually from your unit guide, but it's something that everyone struggles with. Page 44, number 7 in your unit guide. It took a patrol boat 5 hours to travel 60 kilometers up a river against the current. That's the main thing. And 3 hours for the return trip with the current. Find the speed of the boat in still water and the speed of the current. So first of all, we're going to set up the equation. Distance, because we're traveling a certain distance, 60 kilometers, up the river, down the river, whatever the case may be, and we're going to, I'm going to write it down here. The first line is going to represent down the river, and the second one is going to represent up the river. Now instead of x and y, I want to let B represent the speed of the boat and C represent the speed of the current. That's actually will be easier for you to understand. Now the distance for both trips is going to be 60 down the river and 60 up the river. We're covering the exact same distance. However, the time is different. When we travel down the river, it only takes 3 hours. However, when we travel up the river, 5 hours. So you have to ask yourself, why, if we are covering the same amount of distance, how come when we're traveling down the river, it takes us only 3 hours, and it takes us 2 more additional hours when we're coming back up the river? So the reason for this is, and we're going to talk about the boat and the current. So the speed, when we're traveling down the river, the boat, if we say that the boat has a positive force, the current also is working positively. So speed can be represented by B plus C. However, when we're coming back, if our boat is positive, the current is actually working against the boat. So we can write that the boat and the current are working against each other. So the speed is B minus C. And because we know from science class, you might remember this triangle, where distance is on top, S is over here, and time is over here. So if I wanted to solve for time, I would isolate the time. But in this case, I'm solving for D. So I'm going to isolate the D and highlight the other variables. So distance is going to be equal to speed times time. So distance, I know, is 60, is going to be equal to speed times time. Distance is equal to my speed, B plus C, multiplied by my time. Over here, I have distance is equal to speed, B minus C, multiplied by my time. And now we can actually go and solve this question. Don't be fooled. Just because we have a lot of the same numbers, or if my distance is 60 in each case, that doesn't mean that this question cannot be solved. I'm just going to rewrite the equation. So my equation number 1 is going to end up being 3b plus 3c is equal to 60. And equation number 2, 5b minus 5c is also equal to 60. Now if we're going to eliminate this equation, we need to have the same variables. So I'm going to try to eliminate my b variables to try to get 15b and 15b. One of them is equation number 1, and one of them is equation number 2. However, to make that happen, if I look at my 3b, that has to be multiplied by 5 in order to get 15b. So that means the whole equation has to be multiplied by 5. So 3b times 5 is 15b, 3c times 5 is 15c, and 60 times 5 is 300. Now we do the same thing for equation number 2. However, right now I have a 5b, so in order to get 15, I just have to multiply equation number 2 by 3. So every variable has to be multiplied by 3. 15, I get a negative 15c, because negative 5 times 3 is negative 15, and 6c times 3 is 180. So often students look at this question and tell me, oh, well, I have all my b's and all my c's are 15, so they're going to cancel out and get 0, and I'll have no solution. But that's not the case. And we can see that when you actually perform elimination. So when I subtract the equations, because my b's are both positive, the b's are going to cancel out. However, I now have positive 15c minus negative 15c is equal to 300 minus 180. So positive 15c minus negative 15c is going to give me positive 30c is equal to 300 minus 180, which is 120. If we divide both sides by 30, get a final value, c is going to be equal to 4. That means the speed of the current is going to be equal to 4 kilometers per hour, because that's how we measure speed. Now I can find the speed of the boat by substituting c is equal to 4 into equation number 1. And I'm going to pick my original equation number 1 because it's easier to deal with. So 3b plus 3c is equal to 60. But my b term, sorry, I don't know my b term yet. That's what I'm trying to solve for. So 3b plus 3 times, I do know that my c is equal to 4, and everything is equal to 60. So 3b is going to be equal to, 3 times 4 is 12, and when we bring it over to the other side, it becomes negative 12. So 3b is equal to 48, and when we divide both sides by 3, you get a final answer. Is that b is equal to 16 kilometers per hour. So my final answer, my final written statement, the speed of the boat in still water is 16 kilometers per hour, and the speed of the current is 4 kilometers per hour. And these two speeds combined with the total distance is going to be the reason for the length, the time that we came up with, or that we were presented with in the original question.